Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here's information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU actuary. Here's a problem for today. This is a problem a student asked me. Similar problem. I rewrote it a little bit. It's extremely simple, but it may look scary at first. We have random variables x and y that follow the joint probability density function with constant density for absolute value of x plus absolute value of y being between 0 and 1 and 0 otherwise. So this is a uniform distribution on the region which is defined by the condition that absolute value of x plus absolute value of y is less than 1. Find the maximum value of the variance of x given that y is equal to y for y between -1 and 1. And it's pretty clear immediately that the region where absolute value of x plus absolute value of y is less than 1 is the darkened area in the figure below. Of course, you can write it out. Absolute value of x is equal to x if x is positive and minus x if x is negative. Same for y, absolute value of y. And just consider conditions where x is positive, where y is positive, and so on. But we know this, so this is the region. It's a square. It's tilted, but it's a square. And you have the four corner points of it indicated. They are where x is equal to 1, y is equal to 0, where y is equal to 1, x is equal to 0, where x is equal to -1, y is equal to 0, and where y is equal to -1 and x is equal to 0. And the conditional distribution that we're looking at, let's just recall what. So here it is. It's x conditional on y equal to y. And it's, of course, you pick a value of y, you draw a line like this, where all the values of y are equal to that value. And we have distribution on that line segment within that square for the specific value of y. Okay, the conditional distribution x conditional on y equal to y is uniform on a horizontal line at the level of y within an interval lying inside the darkened region that I showed you. We know the variance of a one-dimensional uniform distribution equals the square of the length of the interval where its density is positive divided by 12. This implies that the variance is the largest where such horizontal segment within the darkened region is the longest, and that's for y equal to 0, where x conditional on y equal to y is uniform between -1 and 1. The length of such a linear segment equals 1 minus -1, so it's 2, its square is 4, and the variance is that square divided by 12, so it's 1/3, so the maximum variance is 1/3. And you actually don't need to do almost anything, just see this picture, see the line between -1 and 1, take 2 squared divided by 12, and you're done. Answer C. Please remember this is copyrighted material. The problem was created by me and the solution is mine. All rights reserved. Reproduction in whole or in part without express written permission from the author is strictly prohibited. Good luck in your studies and good luck on the test.